Hello there. In this video, I want to build off the previous video I released, which explains what matrix multiplication is, how do we check for it, and how do we know we've done it correctly. In this video, I want to explain why matrix multiplication is the way it is. And this was never explained to me in my education, which is why I want to put it out there. Now, the explanation I got is from a YouTuber called Ritvik Math. I hope I'm saying that correctly. I've linked his video in the description so you can check it out. And I've come up with a similar example to what he has, just so I'm not straight copying his example, but it is a similar example because this is the best way I found to. Now, what we have here is called a graph, and not a graph in the traditional sense of graphing points X and Y, but a graph that is more like a network. And so what we have here is like an example. Say we wanted to leave city 1 and we wanted to go to city 3, but we've got to take a detour or a layover flight in between. So this network or graph tells us these are the 3 airports I can depart from. D and E are my layover flights, and F, G, and H are the airports in which case I am destined to land. Okay, we can actually look at these as different airports, or we can look at them at different times and go from there. Now, the ultimate question we want to answer is how many ways are there to get from where I'm departing to where my destination is? And this is where matrix and matrix multiplications can come in handy. So I'm going to go ahead and I'm going to set up a matrix going from my departures to my layovers. So in a matrix, this might look like a 3 by 2, in which case I'm departing from A, B, or C. Okay. And I'm arriving at D or E. So a 3 by 2. Okay. Now, how many ways, this is where the matrix comes in. How many ways are there to get from A to D? Well, there's just this one way right here. So I would put a 1 in that entry. How many ways are there to get from A to E? There are 0 ways because I don't have any what are called edges going from A to E. So A, B, C, D, E, F, G are what's called vertices, and the lines or curves connecting the vertices are called edges. So on to B. So I've got B to D, there's 1 way, and there's 2 ways. So I've got 2 ways to go from B to D, and I have got no ways, pardon me, I was starting to look at C, but I want to finish B first. Going from B to E, there are no ways. Now C has this 1 way going to D, and they also have 1 way going to E. So there is 1 way going to E. Okay, great. Now, let's build off that and go from our layovers to our destination. So I would set up a similar matrix, but the way I've set up my original, my rows are where I'm going from, and my columns are where I'm going to. So I want to set it up the same way. Well, if I'm going based off my layover flights, D and E would be where this comes in. Okay, so, and then I'm going to F, G, and H. And now this would be a 2 by 3 matrix. Okay, so D and E, so going from D to F has just 1 way. Going from D to G just has 1 way. Okay, and then going from D to H has 0 ways. Okay, now E to G has 1, 2 ways. And I forgot to mention E to F has 0 ways. And then E to H has 1 way. Now, so far, this doesn't explain why matrix multiplication comes out the way it does. It just shows us how to set up these graphs. Let's set up one more matrix. And let's set up the complete matrix going from A, B, and C to F, G, and H. Say we wanted to skip the middleman. We're still going through our layovers D and E, but this is completing the cycle. So I want to know how many times can I go from A to F. So there's this one way to D, and then once I get to D, I go to F. So that's one way, okay? How many ways are there to get to G? I can go to D, and I can go then to G, okay? So there's one way. Now, we have to remember, with A, there's only one place we can go to, and that's D. And then once I get to D, I can go to F or G. Now to H, there was no way to go from D to H, and I'm only looking at D because I can only go to D from A. So that means there's 0 ways to get to H. And then we complete the rest of the matrix. So from B, I can go to D via this path right here, and then go to F. So that's 1. Or I can go via this path and then go to F. So that's actually 2 ways I can go from B to F, okay? And then similarly to G, I can take either one of those paths and then go directly to G, and that's 2. And then from B to H, well, the only way to get to H is through E, and I can't get from E or to E from B, so that's a 0. All right, now let's talk about C. C, we can go to D, and then we can go to F. That's 1. I can go to D and then go to G. That's another 1. Now, this is actually where I messed up a little bit. I can go to E and then take either one of these 2, which would be a grand total of 3. So I actually need to erase this to get to E. And then I can take my path to E and then go to H, and there's just one way to do that. All right, let me go ahead and copy this onto a fresh slide, and then we will talk about matrix multiplication. 1. Okay, so there we go. We have our matrices set up, and I've even set it up as an equation this time because I know that going from A, B, or C to D or E, and then going from D and E to F, G, and H just leads me with a path that I go from A, B, or C and land in F, G, or H. So the combination of these 2 matrices needs to lead me to the combination of this matrix. Now let's think about what matrix multiplication, what our qualification is. Our qualification is these 2 numbers, these 2 inner numbers right here have to be the same. And in this example, we get a good visualization of why that's the case. We go from A, B, or C to D or E, and then lead to go to F, G, or H. So the 2 columns in the 2 matrices, the 2 columns in the 2 rows, pardon me, in the matrices are set up the same way because they represent the same thing. But that just leads us, what are we ultimately wanting to find out? How can I go from A, B, or C to F, G, or H? And that leads us with the 3 by 3 matrix. Now let's really quickly go ahead and see if we can get a matrix multiplication to show us why that my final matrix is correct. So I've got this times this. So 1 times 1 plus 0 times 0. Okay. And then I get multiplied by this. So 1 times 1 plus 0 times 2. And then I'm going to multiply by this. So 1 times 0 plus 0 times 1. And now we're going to go ahead and work through this row. 2 times 1 plus 0 times 0. And then we're going to multiply by this. We get 2 times 1 plus 0 times 2. Then we're going to multiply by here. That's 2 times 0 plus 0 times 1. And then finally, we're going to go with this row and these columns. So 1 times 1 plus 1 times 0. Sorry, I had a brain fart there for a second. And then this column, 1 times 1 plus 1 times 2. and then 1 times 0 plus 1 times 1. All right, let's go ahead. Well, 1 times 1 is 1, 0 times 0 is 0. That leaves us with this 1 right here. We get a 1 here, we get a 0 here. Add those together, we get another 1. And then notice both of these we're multiplying by 0, which gives us a 0. All right, great. So now we've got 2 times 1 is 2, plus 0. That gives us our 2 here. 2 times 1 is 2, plus another 0. That gives us our 2. And then once again, we got 2 entries here that are being multiplied by 0, giving us the 0 here. All right, we got 1 plus 0 gives us the 1. We've got the 1 plus the 2, which gives us the 3. I'll try to make those the same color. And then we've got the 0 plus the 1, which is the 1. Now, is this how it was derived? Probably not. There was probably more complicated thought processes involved in here, but this is a good explanation of, I think, about why we do matrix multiplication the way that we do. Hello there. This is post-production. I just wanted to add this last explanation because I was reviewing this video and I wanted to take the opportunity. I feel like I missed an opportunity to better explain why matrix multiplication works out the way it does. So I don't have the file with me at the moment, so instead I'm pulled up an enlarged version of the screen. So you have a flight from A to D, okay? And then from D, you can go to F. So that's a 1 times 1. That's where we get this 1 times 1 that's right here. And then you can go from A to E 0 times, and then from E to F 0 times. So that doesn't add anything additional. If we're just talking about going through D and E to get to F, what this represents is A to D to F, that was one way, and then A to E to F, which was 0 ways, which is where this linear combination 1 times 1 plus 0 times 0. Okay, I don't want to give this explanation for all of them. It would be quite extensive and possibly even boring. Let's choose one more. Let's choose B to G. So this row of 2, 0 with this column of 1, 2. So 2 times you can go to B to D, and then 1 time you can get from D to G. So that's a grand total of 2 ways to get from B to G through D. And then you can't go from B to E, so this is why we look at this 0 times 2. Yeah, you got 2 ways to get from E to G, but you can't get from B to E, so we don't add anything to that possible combination. So the 2 and the 1 gives us 2 possible ways to get to G, and then 0 times 2 is the possible ways to get to G through E. So that's where we get this 2 times 1 plus 0 times 2, which of course leads us to here. So if you like this video, go ahead, give it a thumbs up and subscribe, and make sure you leave a comment down in the comment section if you want to see future videos, and I will see you for the next one. Thanks for watching.